What you got?
Just a few graphs on USB, and I just want to make sure if I'm heading in the right direction, sure.
Yeah.
It's labeled, it's in Excel, and it's labeled birth rates.
Birth rates. Okay. Birth rate?
Yep. Oh, okay. So basically what I did was that one set of data points that gave the exact birth rate for since 1910. I used that, and I plugged in the X values as the number of years since 1780.
Okay.
Starting with 120. And then
That's good. Okay.
the Y factor.
So we've got our 120 up through there.
So that's my birth rate function, and
Okay.
I used the line of best fit to, or linear regression to illustrate it.
Okay, now this, again, recognize this is change in population, so I'm assuming this is 1.6 million people, 1.3 million people, 1.72 million people. Okay, so is this number of births, I mean, is this 30 million births and 27 million births, or is this, what's that 30.1?
30.1 is the increase,
Okay.
is a birth rate of per 1,000 people.
Per 1,000 people, right. So that's per 1,000 people. This isn't change per 1,000 people. This is increase, this is absolute increase. So if this is 30 people were born for every 1,000 people, how many people were actually born?
You would have to divide by 10, right?
No. No, you'd have to multiply by the number of thousands of people you have, right?
Oh, okay.
So that's what I was saying, is this birth rate is dependent upon how much population you have. So notice the birth rate's been going down, but since our population's gone up, the actual number of births is actually going to go up. Because you have here, in 120, which was 1910, you have a population of 92 million, right?
Yeah.
So if I multiply this, or that, because I'm looking at how many thousands, right? You said 30 people per 1,000? So there were 92,000 people, so I'll multiply that by 30. And then in 1920, there were 106,000 people, so I'd multiply that by 27. Okay, so then that's what I was saying in the instructions, is be very careful, is the birth rate you find is usually not the number of births per year, but the number of births per large number of people per year.
Okay,
We want, this is change in people per year, these are the units here, people per year, right? Or millions of people per year. So we want this to have the same millions of people per year rates.
Okay,
So you're going to have to multiply through by the appropriate populations to get the total number of births, and then of course you should convert them to the same scale here.
Okay.
So if I found a 1.6 million, I mean, if this said 1.6, I want it to mean 1.6 million births per year. So it would match this 1.6. I don't want it to be 30 per 1,000 per, per something else.
Okay, so...
And of course that 30 also has to, whatever I end up with in terms of millions, I want to convert back down to work out.
So basically, times it by 1,000 and then multiply it by 1.6?
Well, you're going to, well, this is rate of change. This isn't the actual population. Your actual population in 1910 is 92 million. So you're going to divide this by 1,000, because this is 30 people per 1,000 people. You're going to multiply by the number of people you have, okay, and that will give you the total number of births for your total population.
Okay.
And that will be the increase that you're then going to compare. Then you convert it into how many millions of births, so you can convert millions of people to millions of births and show that they're...
And that would be the rates.
Okay, and that would be the rate, because it's per year. Okay,
Okay.
this is a birth rate because it's people per thousands, which is the scaling, but we also have to talk about people per year, which is here.
Okay.
So you're going to have to multiply times pop, or divide by...
So either way, the birth rate function and the average rate of change function have to be somewhat parallel to each other.
So you're going to be doing... Well, I mean, it should be, because if the population's going up and yet the birth rate, the number of people being born is going down, there's a question right there. So you're going to divide by 1,000 and then multiply times population of 1910. And that will give you total number of births. Because that's what we're looking for. We have to compare the births per year to the change in people per year.
Okay. And then the change of people per year would
Right,
look
and your average rate
similar.
of change function, that's fine.
Okay.
And taking your data and making a approximation and looking at what's going on there.
And then basically, and then subtract the two functions together and then find the area under the curve.
Find the area between the two curves, right.
Within the absolute integral between the time.
Yeah, because all you've got is 1910. You can't extend too much further back.
Okay. All right, that is it. I'm closer than I thought.
Okay. Yeah, here, let's save so you get those notes. Yeah, and again, this is one of those problems where, we talk about birth rate and then we talk about other things. If we don't keep track of the units and think about what are those numbers really supposed to represent, it's very easy to say, well, I'll just compare this 30 to this 1.6 and they're supposed to be the same. Well,
Okay.
obviously they're different, but are they different because they're really different because you've been looking at millions of people here versus, thousands or per thousands or, stuff like that.
Okay. All right, I am done. Thank you so much.
So we do get a practice? No.